Hello and welcome to another video in the Genesis Edge product line video series. My name is Charles Johnson. I am the lead trainer slash technical engineer at Lynxspring. And today we're going to be talking about how to apply logic in an Edge 534 controller. So a couple things I've already done ahead of time just because it takes a little bit longer to do is I have created some folders. Now, most of them do not have any logic in there, the fan logic, chill water valve, and damper logic. Those I'm actually going to be doing in this video with you. However, the network settings folder that I have here has a bunch of set points in here, and I've created some links already, and I'll show you how to do that in a moment. But with the damper logic, chill water valve, and fan logic, I will be showing you how to actually use the building blocks, or really kind of just kit control only, with Niagara. So let's get started. In the last video, we know that we created points for our VAV air handler. And I've done a couple things here. I'm going to right click on the wire sheet. And the first thing that you see that I have put my inputs to the left and my outputs to the right. If I were to apply any additional programming, like this little logic right here, I always have space in the middle because inputs will be linked from the right, which means they're coming from the left. And then the outputs are going to be linked from the left, which means it's coming from the right. So in this particular case, what I've done here is with my high static, my smoke alarm, and my free stat, I have inverted the outputs of the inputs here and made an AND block and called it safety's okay. So this safety's okay is actually going to be an interlock for my fan control, which then I'll be using the fan status for the rest of the disable blocks, especially with the PID loops that we're going to be using. Now you may ask the question of how I created these slots here on these folders. Well, a folder by itself, if I go to the AX slot sheet, has nothing in it. But even if I were to add points here, I can't expose them just from the slot sheet like that. If you remember from the N4 TCP class, when you need to expose something that is added to a component, then you are going to composite them out. So what I did is I right-clicked on my folder and I went to composite. And then from here, I was able to expand the folder and see all the components that I have in here. So I have taken all my inputs and have shown only the out slot here. And then I've taken my outputs and have only exposed input 16 from each of them. So as you can see from the nubs on the left and the right, that these here are inputs only and not being written to. And these here are outputs only, which can be written to. For my network settings folder, I have here a bunch of set points. We have the night setback, night setup, occupancy override, and the occupancy command. Now, the night setback, setup, and occupancy override, most likely they're going to be coming from my Niagara network when I have VAVs, right? Because as far as the night setback, setup request, or occupancy override request, those are going to come from the VAV because those are going to be at the VAV level. Whereas my occupancy command will be coming from my schedules folder with a schedule, which I will be linking in another video later on. But in here, I've got some additional set points, such as supply air temp set point, static pressure set point, mixed air temp set point, and outside air damper minimum position set point. I also have a couple others here, for outside air enthalpy, outside air temp set point, all for my economizer logic that I have already created. I did this ahead of time because I knew this video was going to be a little lengthy, and I felt that if I created all this ahead of time, or at least this particular logic ahead of time, I would save a little more rather than it being an hour video. Maybe this will be about a half-hour video. Now, the thing that I also did here for my network settings folder is not only did I expose these set points, I also exposed the actions of my set points and some of the points that I actually wanted to override. So I can actually right click on this network settings folder and actually set all my set points from here and even override my occupancy command and even my economizer command if I wanted to. And I like doing those kinds of things just from here in case you actually don't want to do anything from the graphic. And it actually means that you don't need to get into the logic folder unless there's an issue with the logic itself. You can actually just set and override everything from here. Okay, so now the first logic I want to do, which I think is the easiest, is actually going to be the fan logic. So with my fan logic, I want to be able to turn it on when we are in night setback mode or night setup mode, or if someone has pushed the occupancy button on a VAV, or if if the building schedule is occupied. I also want to make sure that my safeties are okay to make sure that the fan starts if none of the safeties are there. Now, while normally these can be hardwired interlocks, sometimes they may not be. So I also prefer to have a software interlock as well as a hardware interlock. So I'm going to double click my fan logic folder. And since I know I need at least 5 things, I need to have 5 slots. Now, you do not have to you don't have to composite any slots if you want. You can use the link mark action if you wanted to. I prefer to do it this way just so that it's easier for someone to see where things are being linked to or linked from. So if I know that I need to build some logic, well, what palette do I need? I need the kit control palette, but you see right now I have no palette window open. So I'm going to go to my sidebar and I'm going to select the palette sidebar. But now it's blank, and that's because I have no palettes that are open. Any palettes that you had open will actually still show up here, but I've shown you here in this particular case just to show you how to open up a specific palette. And I'm going to open a palette by going to the Open Palette window. I select Open Palette here, that's this folder icon. And now I'm going to select or just type in Kit. And now I can see here Kit LON, Kit PX. I'm going to select Kit Control. 99% of the logic blocks that you're going to be using in Niagara without any additional third-party modules will be used in the Kit Control palette. And there are many useful blocks that are here, such as in the HVAC folder, we have the loop point, a T-stat, the lead lag runtime, and even raise lower. Now, some of you may not be familiar with the raise lower, especially if you're using floating control. Raise lower is super good. Then for the energy, which I've already used, I've used the psychrometric block, which allows me to look at enthalpy, wet bulb, dew point, those kinds of things. Then if I wanted an optimized start stop, I can actually drag that block in here as well. Then with my logic, I can use and, or even not blocks. I already used the not block once, or actually 3 times. But then I have my compare blocks, which are greater than or greater than equal to, less than or less than equal to, or even not equal. If you wanted to get special, you could bring in the expression logic block and create mathematical functions doing so. The math folder gives you all your math options, your absolute value, your add, subtract, multiply, divide, even some additional min-max if you needed to create a negative number. The reset is also really good. I will be using this as well. Then in my util folder, I have a bunch of switches that are really useful, the min-max average block. I even have a ramp and a sine wave block. Now, the ramp and sine wave you would use, especially in testing. When I do the N4 TCP class, we use the ramp and sine wave to create a simulated value to uh, to test our logic. And if you're not testing this live, feel free to add the ramp and sine wave blocks, to your temperatures just to make sure that everything is working the way that you think it should. So, assuming that we have a sequence of operations, and the sequence of operations says the fan needs to run either from an occupancy command from a building schedule, from the push button overrides from any of the VAVs, night setback, or night setup mode. I know that any of them will cause my fan to turn on. So with that, I don't need an AND block, but I do need an OR block. So I'm going to drag the OR block from my palette onto my wire sheet of my fan logic folder. And I'm going to name this fan start OR. And the reason why I like to name my logic blocks is that so you know exactly what it does. And I'm going to pin out C and D here because I need all four. And then I'm going to bring in an AND block because I also want to be able to have my safeties okay in order for my fan to start. So I'm going to say AND safeties. So I'm going to drag my out slot, and I'm going to rename this here to safeties properly. And now this here is going to be, all these points here, these inputs are going to be exposed on my folder. And then from this out slot, I'm just going to create a fan variable. I'm just going to say fan SS for fan start stop. And I'm going to double click this and change my facets from start and stop. I don't need a fallback value here, but if you wanted to, you absolutely could. And now I'm going to link from my AND the out slot to input 16 of my fan start stop. From here, I'm going to go back to the wire sheet of my points container. And now I'm going to composite out my fan start OR, my inputs, my fan safety in B, and then my output for my fan. And I'm going to name this awk override, awk command, night setback, just or NSB for short, night setup or NSU for short, and safeties, and then say fan out. Now I can drag my safeties over to my folder. I can then drag my night setback out to my night setback, my night setup to my night setup, my occupancy override, and then my occupancy command. And I can reorder these to make sure that these actually look a little better, or if I wanted to, I could just readjust it this way. To make it look neater. It's really up to you. And again, you don't have to do any of this, but this is just easier to look at the logic as a whole. And that way you can you can compartmentalize your logic uh, in order to better communicate or to better lay out your programming. The next thing I'm going to show you is how to use a loop block because we do have a VFD here as well. So in order to in order to modulate a VFD or to modulate an output, we are going to be using the loop point block, which is under the HVAC folder of my kit control palette. And I'm going to drag this in and I'm going to name this static PID. Now, think of a loop point as cruise control on your vehicle. So you're driving on the highway and you want to maintain a specific speed. So you're going to set your cruise control to a specific speed, and the car is going to modulate or rev up the engine or rev down the engine in order to make sure that that you maintain the specific speed. Same thing here applies for a loop point. And as I go here, we're going to have a couple things. One, we're going to have the loop enable. So this is going to enable or disable the loop. We have the controlled variable, which is your input. And then we have a set point. Then we have the loop action, which is going to be direct or reverse. In this case here, because it's a static pressure, if the static pressure goes down, I want my fan output to increase. So it's going to actually be reverse. Then we have the proportional, integral, derivative, and bias. Now, bias is that what I want my output to be when I'm at set point. So for me, I personally like to keep my bias at 0, but many people like to keep it at 50%. It's really a matter of preference to you and how you feel that you should control your output. But the easiest way to tune a loop first is to start with a proportional constant. And then, choose a number. If you are maintaining something like a space temp, you want it to be very small. And if you want it to be like a supply air temp set point, it's going to be a wider or a larger proportional constant. And then if you need additional support on there, then you'll actually want to change the integral constant. But the ramp time, I'm going to change as well. Now, the ramp time says I'm going to go from 0 to 100 in X amount of time. So for here, if I start with 3 minutes, that means that it's going to take 3 minutes to go from 0 to 100, even if my output already says even though if my output should already be at 100, it's going to ramp up within 3 minutes. So I'm going to start with a proportional constant of 15 and an integral of nothing. Now, in a video series later on down the road, I will probably be showing you some additional pieces of logic that you can add or create in order to better control your pieces of equipment, such as like a hysteresis block. Maybe we'll go through actually enhancing the loop point to where it works like something that you would see in a regular controller outside of Niagara. I'm going to select save. My facets, though, I'm going to change to percentage, and my input facets I'm going to change to my static pressure. So my inches of water column is what I'd like to do. I'm going to select save. Now, I'm going to pin out some slots, and you don't have to do this, but I like to do it again, just because if someone's going to come behind and look at my work, I want to make sure that they have all the information possible with the fewest clicks necessary. So I'm going to right-click on my static PID and pin out some slots, and I'm going to select the loop enable, the control variable, the set point, the action so you can see it, and then I'm going to bring out the proportional integral, min-max, and then the ramp time. And actually, I will also do the bias as well. Okay, so now we know that the fan start-stop here. I'm going to create a numeric writable that says SAF VFD. And I'm going to change the facets here to percentage. I'm going to link the out slot of my loop point to my in slot of my in 16 of my numeric writable. And I'm going to expose the loop enable, the control variable, and the set point in my folder like I did before. So I'm going to right click on my points container and go to AX wire sheet. And now I'm going to composite out from the static PID the loop enable, the control set point, the control variable, the set point, and then the out of that. Then I'm going to take the VFD and I'm going to take the out slot of that. And so now I'm going to say fan status because that's what that's what I want to link to my to my set point. To my loop enable. My control variable is going to be static pressure. So I'll just type in static. My set point is just going to be static SP. And my actually I don't need the output of the static here because I'm already linking to the static VFD there. I'm going to go ahead and remove that and then just say SAF VFD. So now I'm going to find my fan status input here. And do I have it? I do. So fan status is going to come in from here. My static pressure will also come into here. My static set point will come into here. And now my fan command is going to go into my fan command in, and my supply VFD is going to go to my my fan speed in here. And now we're going to get into the chill water valve logic. So for our chill water logic, it's going to be quite simple. We are just going to modulate the chill water valve to maintain a chill or a supply air set point without the use of economizer. With this having economizer, we could easily put in logic. To say, hey, if the damper is open, let's say 100% for more than 15 minutes, go ahead and enable the chill water valve to allow more cooling because we're assuming that we're either very close to economizer or just slightly over it, and we can no longer maintain. So to do this logic, all we're going to do here is we're going to copy from our folder here, from our fan logic folder. We're going to right click and copy the supply static PID and the SAF VFD command. And we're going to paste it right here in our chill water logic. And we're going to rename these 2 points. Right click, rename, CHW VLV PID, and CHW valve command. Ooh, D and not C. Okay, so here for a chill water valve, it's not going to be reverse acting, it's going to be direct. And I'm going to change the proportional constant to 25 here. And the rant time, I'm still going to keep at 3 minutes. And the input facets, I'm actually going to change to degrees Fahrenheit. And select save. So for the enable, I need several things. One, I need to make sure that we're not in an economizer. Two, I need to make sure that we are occupied or if the push button occupancy was overridden. And we also need to make sure that the fan is running and we are in night set up and not night set back. So doing this, I'm going to go ahead and go to my logic. And I know I'm going to bring in an OR and an AND block. So for the OR block, again, I need to make sure that we are in night setback, occupied, or uh, uh, or um, or the occupancy override. So I'm going to use 3 here. So I'm going to pin out A, B, and C. I also need to make sure that we have fan status and then we're not an economizer. So I'm going to put a not here and just put not econ. And we're going to say this AND block is the valve and the PID enable. So we're going to drag this OR block into NA. We're going to need the not econ in NB. And then we're going to need the fan status. So we're going to pin out the slot to go to NC. And then we're going to drag the out slot to the loop enable. And then from here, we just need a composite. And in order to composite, we right click on the object and go to composite. So the OR block, we're going to do in A, in B, in C. For the not econ, we're going to drag in the in. And then the pin enable, we're going to do input B, or input C, sorry. So we're going to say here, oops, sorry. We're going to make this one awk command, awk override, and night setup. Then we'll say econ, and then fan status. Okay. And when we do that, we see all these nubs that happen that show up. And then we right click on our wire sheet of our points container. And we will take the night setup out and go here. The awk override out here. The awk command out here. The econ out to the econ. The fan status to the fan status folder. And there's one thing that we did forget. We forgot the actual chill water valve. So we take the command here, and we're going to rename this chill water valve. VLV. Click OK. And now drag the chill water valve out here. And now we're going to get to the damper logic. Before we get to the damper logic, I forgot to composite out the supply air temp set point with the logic. So I went ahead and composited those out and linked them up, so everything should work and everything should be linked there. And now we're going to go to the damper logic. And as I go to this folder, I need to figure out how I want to control my outside air damper and my relief damper. Without a building static pressure sensor, the relief damper can actually just follow the same signal as my economizer dampers, because my economizer damper, the outside air, and the return air damper are linked together in this scenario. So effectively, whatever the outside air is doing, the relief damper can also do. Now, how do I want to start this? Well, I can take the chill water valve PID and the chill water valve command and copy them like I did for my fan logic and paste them into my folder. And I would like to rename. I'm going to keep the same proportional constant here. However, I'm going to rename my mixed air temp, my chill water valve PID loop to econ PID. And I'm going to break the link here between this. And I'm going to rename this econ damper command. Everything else is still the same here as units in percentage and whatnot. However, I'm going to be adding some additional logic in between. And I could add it between the min and max output here as well, but I like showing the logic on the side from the loop. So the first thing I want to do is I need to figure out how I want to enable my loop. Well, if we are occupied based upon the building schedule or the push button override, and we have fan status, and we're an economizer. Now, you may ask, why not night setup? Because typically it is assumed that night setup, the only way the building is going to get too hot is if we are in the summer season and there's no cooling there. So normally in night setup, you're not going to use the damper because if we are in the wintertime, you most likely will have a night heating rather than a night cooling. So I'm going to drag out an OR block, and I'm going to name this awk OR, like I did in one of my other piece of logic. And now I need an AND block to give me econ fan status awk AND. So just something renamed very quickly. And so I'm going to link my OR to my NA, and I need the fan status and the occupancy. So therefore, I'm going to pin out the slot here and go to NC. And then I'm going to enable my loop based upon that. Now I'm going to pin out, or not pin out, I'm going to composite out my controlled variable and my set point as well. But a couple other things I need to do. The control variable in this case is going to be mixed air temp. And I created a mixed air set point under my network settings. Now, what comes after here is going to be a couple different logic blocks. Well, the first one I'm going to do is I'm going to create a numeric switch. And this is the first time I'm going to use my util folder here. And I'm going to drag out a numeric switch. And this numeric switch is going to be min POS switch. And pretty much what this is going to do is that this is actually going to switch between the minimum position set point and 0 based upon my fan status. So I'm going to be compositing this out here. Then I need to drag out a min block and a max block. And that's going to be under the math block. So I have a min, a max, and actually a reset block. And the reset block I'm going to name MATLL for mixed air temp low limit. So what I'd like to do is I would like to limit the damper position based upon a drop in mixed air temp from 45 to 40. So effectively, for every 1 degree, it'll be 20%. So the first thing I'm going to do here is I'm going to take the out from my PID loop and drag it into my maximum in A. And then I'm going to take the minimum position switch and I'm going to take the out and drag it in B. So if my loop is disabled, which most likely could mean that I'm not an economizer or occupied, then I want my min position to be 20%. But of course, my fan status is off. I want it to be 0. Then I'm going to take my mixed air low limit that I have created here, and I'm going to use that to limit my damper position. So I'm going to drag from the out of the max block into NA and the out of the reset. And then I'm going to drag the out of the minimum into input 16 of my econ damper. I'm going to double click my reset block here, and I'm going to change my input and output. So my input low is going to be 40, and my output high is going to be 45. Now again, these are numbers that I have made. In the real world, you may make it 38, you may make it not. It depends upon whether or not you want this to get close to the free stat trip point. And my output low is going to be 0. My output high is going to be 100. And I'm going to go ahead and change the facets to percentage. And if you want to, pin out those slots as well. That way everyone can see what's going on. And then from here, I'm going to composite out everything I've done. So my awk or, I'm going to put in A and in B, and this is going to be awk command and awk override. My fan switch, I already have input A there, so I need B and C, which is going to be econ, and then fan status. Then for my min position switch, my in switch, actually, because it's going to be fan status, I can drag that right into here. So that's going to work out in my favor. And so when I composite this again, I just need the in true of my switch and name this min position. Ooh, I did not save them. So let's go and remove it. Let's go ahead and do this again. Again, awk or in A, in B. So awk command, awk override. In B is econ. In C is fan status. Now my min position switch, my in true is going to be min position set point. My PID loop, I need to bring out the controlled variable, which is the mixed air temp, and my set point, which is my mixed air temp set point. Let's see, MA temp, MATSP. And then I can take the econ damp command and go to the and say econ damper out and click OK. And now let's make sure that we have everything that we need. Well, this is supposed to be linked from the mixed air temp set point. So I can actually take the control variable and actually drag it into my input. So now when I link my mixed air temp, it's going to be linked into here as well. And so now I'm going to go back to my AX wire sheet of my points container and awk command and awk override. Those outs are going to go here. Awk command, awk override. My econ out is going to go here. Fan status is going to go here. My min position set point. OADSP. My mixed air temp set point. My mixed air temp itself. And now my econ damper can go into my econ in and my relief in. And the last links I need to make are from my outside air temp and return air temp and humidity, both of them. So I take the OARH and the OHR in, OA temp to OAT in, the RA temp into RA temp in, and RARH Command RHRAN. So now I can see that I have values that are in here. And now I can see from my damper logic, if I click here, that my mixed air temp was brought in, and now it can read it through my mixed air temp low limit. The last thing that I'm going to do is my occupancy command itself. However, I would like to discuss that more in depth in the next video, which will be dealing with schedules. Okay, I'll see you later. Have a good one.